Hello, this is Sean, and my project is on network threat exposure intelligence. So the first data set is historical network intrusion data. The data will be combined with additional ASN data, which is information about the organization that owns the IP address initiating the network transfer. Data will also be prepared via transformation and the creation of indicator variables. Exploratory analysis will be performed using methods of applied probability and statistical inference to understand the qualities of the data. The data will then be used to create a classification model to classify network transfers as malicious or benign. Logistic regression must be used because the target variable is binary. Live data will then be prepared using the same steps and fed into the model. The results will show how much malicious traffic the company is exposed to. The IT team will interpret the results, and changes over time and after policy changes can be assessed using hypothesis testing to test for a difference in the proportion of traffic that's malicious. This will assist in decision making, such as changing security policies and adding additional security tools. Changes will cause the profile of the company traffic to change, which can then be reanalyzed in a cyclical way. So the data necessary for a classification model is available and quite robust. The first data set is from Kaggle and contains historic network traffic data labeled as malicious or benign. The variables used for the model are bytes in, bytes out, packets out, and duration. Because packets vary in byte size, and a common form of malicious traffic is attempted injection of malicious code, there might be an interaction between bytes in and packets in. An interaction term may capture differences in the way bytes are compiled in the packets of malicious traffic. The ASN data that's added contains categorical variables for region, traffic ratio, which is, for example, heavy outbound traffic, mostly inbound traffic, and so on, and traffic estimation, which is the amount of data per second that's transferred to and from the IP addresses owned by the ASN. Lastly, age is the age in days of the ASN. Indicator variables need to be created for the three categorical predictor variables: region, traffic ratio, and traffic estimation. To investigate whether the variables have predictive power, applied probability will be used for descriptive analysis. For example, there's a 58.6% chance that a record in the dataset is malicious if the logged number of packets in is between 1.75 and 2.25. Statistical inference will then be used for further exploratory analysis to understand the qualities of the data. For example, t-tests can be used to see whether there are significant differences in the sample means of the variables between benign and malicious flows. Next, logistic regression will be used to build a classification model. Initial results show the logistic regression model does a good job at classifying with accuracy around 86% in the test set. Finally, hypothesis testing will be used for live data analysis. Two-tailed tests can be used to test whether estimated proportions of malicious traffic vary across time periods. So logistic regression must be used for the model. The objective is to create a classification model, and since the target variable is binary, logistic regression should be used. Also, the probabilities determined by a logistic regression model are more robust than a linear probability model. In summary, the data used in the BI solution is network traffic data and ASN information. A model to classify network transactions as malicious or benign will be built with logistic regression. Live data from the company's network will be fed into the model. The solution will have meaningful results, such as determining markers that indicate a network transaction may be malicious, allowing the company to quantify its exposure to malicious traffic, assist in decision-making by determining whether changes in malicious traffic exposure have occurred, and adding an additional layer of protection to the company's network security. Thank you for watching.